Okay, so hello class. This will be our first attempt to pre-record the video in our discussion of differential calculus. Now, I have already given you your lecture notes with the topic functions in our MS files, and please kindly download it and read it so as to know the introduction regarding functions. Now, the purpose of this video is for me to be able to show you the solution of the sample problems there in your lecture notes. So I will go slowly on this since I have learned that not all of you are STEM students or from the STEM strand. So I will go slowly, and if ever there will be some technicalities, please I am asking for consideration regarding that, for I am new in this kind of modality. Okay, so here functions, we will be solving example number 1. So if you look at your copy of the lecture, you have their example number 1. Says there, if f of x is equal to x squared minus x plus 3, find the value of f of 0, f of 2, f of negative 4, and f of negative 2x. Okay, what does this mean? So in the lecture notes I have given you, there is the independent variable and the dependent variable. So here, the f of x here is your dependent variable. Why? Why is this your dependent variable? Because the value of y depends on the value we are to assign with x. So x here is your independent variable. So whatever you put in x will become the value of y. That is why your variable y here is dependent on the value of x. So what this example is asking is, what will be the value of y if x is 0? So basically that is what this example is asking. So let's start to solve them one by one. So if you can see here in our example number 1, it is asking for how many dependent variables? Well, it's asking for 1, 2, 3, and 4. So we will be solving for 4 values of y. Now, let's solve for f of 0. What is the value of f of 0 here? So we will just substitute x with 0. So I will be putting parentheses whenever I make substitution. So 0 squared minus 0 plus 3. So this obviously has the answer of 3. So that's it. That's how you go about it. Some basic algebras. So let's proceed with the next one. What is the value of f of 2? Now for f of 2, we will just substitute 2 for x. So 2 squared minus 2 plus 3. So this becomes 4 minus 2 plus 3. And the value for that is 5. So simple? Yeah, quite. That's how it is. When we are talking about new topics, of course, we will start at the simplest form, right? Well, you cannot just tell a baby to run, right? You are to assist a baby in order for it to learn how to walk. And then later, if it grows old, then it will be able to run. So that's how we go about our lecture. That's how I go about our sample problems. We will be starting with simple problems and then proceed to the much harder ones so that you will be knowledgeable as for the fundamentals of the topic. Okay? Now let's proceed to the next one. Finding the value of f of negative 4 in the equation. So that will be substituting the value of negative 4 in x. So that is negative 4 squared minus, now look at this. Now this is the reason why I want to use, I want to use parentheses whenever I make substitution. Why? It's because whenever I substitute a value of negative sign, we will not be able to confuse it with subtraction. For example, if I will not put a parenthesis here, it will somehow look like this. Negative 4 squared minus negative 4 plus 3. Now obviously you will know that this will become positive, so you will put there positive plus 3. And then what happens? You might start to square this value here, this 4, and you will have negative 16 plus 4 plus 3. Now I have seen this error in some of my students before. So the only solution to solve this kind of error, or to avoid this kind of error, is to put a parenthesis whenever you make a substitution. So this is wrong. Okay? Now this one here is correct. You put a parenthesis. If this is x here, okay, so you will be substituting x with negative 4. So that's how it is. If this is x here, you will be substituting it with negative 4. So you can see the pattern. The parenthesis separates it from the outside. Or basically in our second term here, it separates the negative sign with the minus operation there. Okay? So that's the benefit of using parentheses. Right? So let's continue solving. Now this becomes, what happens when you square a negative 4? That becomes a positive 16. So unlike what we did a while ago, it became a negative 16, right? And that is wrong. So this is different with this. So these two here are two different values. Okay? So that's how important parenthesis is. Now I am emphasizing that because sometimes we tend to forget. Now we need to make repetition sometimes for the idea to be imprinted in our mind. Okay? So we have there positive 4 plus 3. Now the answer here is 23. Okay? And the last one, for example 1, is f of negative 2x. So we will just substitute negative 2x with x. So we have there negative 2x squared minus the parenthesis. See that? The benefit of the parenthesis. So this becomes, well, what is twice of negative 2? Well, that would be positive 4x squared. That is negative times negative, that would become positive 2x plus 3. So that's it. That's the answer. Wow. When you got used to constant, and then you have an equation, well, don't look for constant here. That's already the answer, the equation here. Okay? So that's for your example number 1. Now, if ever you'll be able to, or if ever you have a question, you can message me, or you can chat that in our group chat, so that the whole class will benefit whatever your question might be, because whatever question you may have in our example might be a question some of your classmates have. So never hesitate to ask me clarifications or questions, so that you will all benefit. Okay? So we have there example number 2. I hope it's clear how we solve example number 1. Alright, in example number 2, it says there, if f of y is equal to y minus 3 squared, find f of c, f of -1, and f of x plus 3. Okay. Oh, it became y. Why is it? It's not x. Well, x, y, z, we use that as variable. C, a, b, c are usually used as constants. You will be encountering that in your mathematics, engineering mathematics, I think, that subject. Okay, so here we will be using x, y, z as variable. Then we have there a, b, c as constant. So we will be solving how many dependent variables here? How many? We have there 1, 2, 3. So let's solve for the first one. What is the value of f of c? Now f of c here means what will be the value if x, or in this example, what will be the value if y is c? So we will just substitute y with c. So see that? The parenthesis. Oh, how about this one? The original equation has already a parenthesis. So what will happen? So we will be using again your parenthesis c minus 3. There you go. Different. So what's this? That is c minus 3 squared. Sorry about that. I don't know where the pause button for this one. I just have to grab some water. Drink some water. Okay? So here, this is already the answer. Okay, as simple as that. So we have there, the next one is f of -1. Then again, we will be substituting a negative value inside the parentheses, of course. So your y there becomes a -1. Then you have there -1 minus 3. Then convert the parentheses there with that. I think it's a bracket. Okay? Square. So that becomes -1. What happens here? -1, -3. That becomes -4. So -1, what is -4 squared? That is 16. Positive 16. So the final answer here is -16. Okay. So that is the answer for the second one for example number 2. Now for the third problem, we have there f of x plus 3. Okay, so what happens? We will just substitute y with x plus 3, then another x plus 3. So don't forget bracket 3 squared. Now is this still the same with that one? Well, this is the y, this is the y, so nothing changed, right? So it's still the same. So let's simplify. We have there x plus 3. This becomes x plus 3, removing the parentheses here, 3 squared. Okay. So what happens here is we just remove the parentheses, this one, combine it with the whole equation inside this bracket. Okay? So that becomes x plus 3. Then cancel 3 and negative 3. So what's left here is x squared. Final answer here is x squared, x plus 3. Okay? So this is your answer. Now, what if my answer is, well, I distributed x squared. X squared, or when I distribute this one inside the parentheses, what happens? That becomes x cubed plus 3x squared. Is that acceptable, ma'am? Yes, I will still accept this answer. So you have there two possible answers for this. So you can have them both. Still correct. Okay? So that is your example number 2. Quite easy, right? So I think it is still manageable. Now how about the last problem? Last example, rather. That is example number 3. It says there, find the value of f of 0, f of 2, and f of x plus 5 of how many? Of a f of x equals 2x cubed minus 3x squared minus 5x plus 2. Okay, so the equation is getting longer and longer. So how many values are we going to solve? How many? There's 1, 2, and 3 values out of this one equation. Okay, so let's start. Let's solve first for the value of f of 0. So what is the value of f of 0 for this equation? Let's substitute 0 with x. So as you can observe, we are substituting whatever value here to the variable being used here. Okay? 2 times 0 raised to 3, negative 3, 0 squared minus 5, 0 plus 2. What happens? Well, this is 2 multiplied to nothing, 3 multiplied to nothing, 5 multiplied to nothing. What's left is positive 2. And that is the answer. Quite nice? Yeah, quite nice. Now B. What is the value of f of 2? Now for f of 2, we will be substituting the value of 2 in x. So concentrate in this equation. So we have there 2 multiplied with 2 raised to 3 minus 3 times 2 raised to 2 minus 5 times 2 plus 2. So what is 2 cubed? That is 8. Minus 3, 2 squared, that is 4, minus 10 plus 2, this becomes 16, minus 12, minus 10, plus 2. And that is what? So, what happens here? This is 16 plus 2, that is 18. Minus, that is 22. So, the value is negative 4. Okay? Quite easy. I hope so. Alright. So, I'm sorry about this. This should not be B. Right? It's not B. Sorry about that. Okay. Now, the last one is f of x plus 5. So, this equation here, the x value is substituted with x plus 5. So, we have f of x plus 5. Then, using the equation, the original equation, you have there 2. The value of x becomes x plus 5 raised to 3 minus 3. The value of x becomes x plus 5 squared minus 5 times x plus 5 plus 2. Okay? That becomes what? Oh, this is rather much more complicated. What is 2 times or 2 multiplied with x plus 5 cubed? Now, this one here, you can expand that. We will be expanding that in 2 different ways. So we can have the what we call the house method. They call it house method. I don't know what's the technical term for that. So this is how it is. We have there x plus 5. Then we have x plus 5. And then x plus 5, right? So cubed of x plus 5 means 3 times the x plus 5. Okay. So let's have first the first 2. X plus 5. Why we call this the house method? Well, we have the roof. And then the leftmost, multiply the leftmost, multiply the rightmost, and then multiply the middle, and then multiply the outside. So that's what it meant by the house method. Okay, so how is it? X times x becomes x squared. 5 times 5 becomes positive 25. 5 times x becomes positive 5x. X times 5 becomes positive 5x. So this is what I mean. Okay. So what happens? You bring down the one on your leftmost roof, x squared. You do some summation here since they're both positive. So this is plus 10x. That's from the middle. And then the rightmost of your roof, that becomes 25. So you bring this down, bring this down. So that's the house method. Then what happens? After doing the x squared, this is only x squared because there's only 2x plus 5 being multiplied. So the value here is taken and this is to be multiplied with x plus 5. What will happen with this one? We will be using the distributive property. So we'll multiply x first with every term in the equation. So that becomes x times x squared. That becomes x cubed. X times 10x. That becomes 10x squared. Then we have x times 25. That becomes 25x. Okay. So we've done with x. So what's next is the 5. 5 here will be multiplied with x squared, then multiplied with 10x, then multiplied with 25. So what happens? What is 5 times x squared? That is 5x squared. 5x squared. Wait, they are two different exponents. So no, don't do that. Let's put 5x squared to where it is similar, and that is 10x. 5x squared and 10x there. Okay, next we have 5 times 10x. The answer there is 50x. So similar to that is the term 25x. So your 50x is here. Then another one. What is 5 times 25? 5 times 25 is what? That is 250. 250 or 125? Let's say 4 times 25, that becomes 100, right? Another 25, so that becomes 125. Okay, I'm sorry I don't have any calculator with me right now. Okay, so let's do some addition because they're all positive here. X cubed, this is positive 10, positive 5, that is 15x squared. Then we have there positive 25 and positive 50, that is 75x, and then we have 125. That is the answer for the expanded x plus 5 raised to 3. Now there's another method we can use for this. They call it the box method. Why box method? Well, we will be using a box, obviously. So the concept here is if we are to multiply first the 2x plus 2 and x plus 5 and x plus 5, so we have there x plus 5 times x plus 5, right? So we have there a box consisting of 4 small boxes for these 4 terms. Okay, so you have there x plus 5, then we have x plus 5. So what is x times x? So this one, x times x goes to there, then 5 times 5 goes to there, 5 times x, and then x times 5. So that's how we will go about it. Right? So what is x times x? X squared, 5 times x, that is 5x. X times 5, 5x. 5 times 5 is 25. Now, the diagonal, observe the diagonal, it has the similar terms. So, if we get the expanded form, this becomes x squared. So whatever is in the box actually is the answer. X squared plus 10x plus 25. So similar with that one. Okay, now we're not done yet. We will still multiply x squared plus 10x plus 25 with x plus 5. So can we use box method for that? Yes, definitely. We can use the box method for that. Again, the number of small boxes depends on the number of terms. How many? 1, 2, 3. So we will be using 3 columns, and then we will be using 2 rows. This is your x squared, 10x plus 25. This is your x plus 5. So x squared times x is x cubed. 10x times x becomes 10x squared. Then 25 times x is 25x. X squared times 5 is 5x squared. 10x times 5 is 50x. Then 25 times 5 is the 125. So observe that the diagonal has the similar terms. I'm sorry, forgot the x there. Okay, then collect all the answers inside the box. That is x cubed plus 5x squared plus 10x squared, that is 15x squared, plus 25x plus 50x, that is 75x, plus 125. So as you can see, we arrive at a similar answer. So whatever solution you want to use, well, it's up to you which one is easier. I'm not that strict with whatever method you will be using with this one. So as long as you arrive at the expanded form of x plus 5 raised to 3, then that's good for me. Okay? So our time has been consumed with just expanding x plus 5 raised to 3. Alright, so let's continue with our discussion. So we have there 2. So the value now for x plus 5 raised to 3 here is, now where is it? Oh, there. X cubed plus 15x squared plus 75x plus 125. Okay, that's just the first term. Now how about the rest? The other one is negative 3. So this one. Negative 3. So what is twice of x plus 5? We got that a while ago, right? That is x squared plus 10x plus 25. Where is that? That is this one. Okay. Now the next one here is the negative 5. Negative 5x plus 5 plus 2. Don't forget the plus 2. So the secret here is being organized with your solution. Now most students, especially when they hate math, when they see a lot of numbers in front of them, they start to panic. The reason why there's a panic is there's a lot of numbers in front of them and it's not organized. But when you start organizing your solution, you start to see it simpler and easier to solve. So I suggest whenever you solve problems in mathematics, make sure that your penmanship is readable and in the right size or font size in order for you to organize things, right? So actually this takes practice. The more you solve problems, the more you adapt the best practice when it comes to solving mathematic problems. Okay? So let's simplify. As you see the pattern actually is you substitute and then simplify. That's how it goes always. Substitute, simplify. Okay, so let's distribute the first one, that is 2x cubed plus 2 times 15 x squared, that is 30 x squared, plus 2 times 75 x. So what is 2 times 75x? That is 150. So 150x plus what is twice of 125? That is 250. Oh, I'm sorry with this one. I've been talking about organizing. Okay. I'm just still getting used to this type of gadget. Sorry. Okay. Next, negative 3. Negative 3 multiplied with x squared, that is negative 3x squared. Negative 3 multiplied with 10x, that becomes negative 30x. Negative 3 multiplied with 25, that becomes negative 75. Okay? Next, negative 5 multiplied with x, that is negative 5x. Negative 5 times 5, oh, sorry, that should be negative 25. Then don't forget plus 2. Simplify again. Okay, so how do you organize that one now? Well, if you're using just black ball pen, you can use different shapes for similar terms. Or if you're using ball pen with different colors, you can just circle the like terms with the color you like. So here, for example, we are using only black. Okay. Oops, sorry. Yeah. So if we are just using only black ball pen, so is there any term here similar with 2x cubed? None. So let's write here 2x cubed. How about 30x squared? There's 2 of them. Now I will be putting it in a box including the positive sign. Then this one here, including the negative sign. So that I will remember that this one is negative. So what happens? What is positive 30x squared plus negative 3x squared? This becomes subtraction. So 30x squared minus 3x squared is positive 27x squared. You always you always follow the sign of the larger number. Okay? So what's next? Positive 150x. So let's put that in a oblong. 150x similar with negative 30x and similar with negative 5x. So there is 3 of them. What is positive 150x minus 30x minus 5x? So 150 minus 30 is 120. 120 minus 5 is negative 115x. Next, Okay, so what's left is constants. The constants here, underline it, positive 250, negative 75, negative 25, negative 20. Now, if you're uncomfortable with the underline, you can just not use underline for the constant because it's already obvious. We have constants here and they are 4 constants. So what is 250 minus 75 minus 25 plus 2? So we have there 75 or negative 75 and negative 25 already is 100. 250 minus 100 is 150. 150 plus 2 is 152. So there you got the answer finally. So that is the final answer. Ooh, very tedious. 2x cubed plus 27x squared minus 115x plus 152. So that is the answer for example number 3, letter A. So if you have questions about this, you can ask me later on. Right, so let's solve for letter B. So remember, we are looking for, says there, find f of 0, f of 2, and f of x plus 5 of the letter B. What is the equation in letter B? So one of the dreaded format of equation is the what? Oops. Fractions. Oh, now we have fraction. So here, first one, quite easy. You'll just have to substitute 0 with every x. So you have there 0 minus 0 squared. Why is it that we're so happy with nothing in mathematics? Because it's always easy, right? So we have there nothing over 1. So the answer here is 0, right? 0 divided by 1 is 0. You divide nothing with 1, it's still nothing, okay? So we have there, the second one is f of 2. So substitute the value of 2 with every x. 2. Okay. So we have there 1 plus 2 squared. So what happens here? 2 minus 4 divided by 1 plus 4. So 2 minus 4 is negative 2. Then 1 plus 4 is 5. The final answer is negative 2 over 5. Now, the other one is so much more complicated. F of x plus 5 to replace x in the original equation. Okay, so x plus 5 minus x plus 5 squared 1 plus x plus 5 squared. You should always be careful whenever you make substitution, because sometimes when you're not focused in your substitution, you might be writing 2 here instead of 5. So that is very disastrous if you mistakenly put there 2 because you kept seeing 2 here. It happens a lot with students. So they usually call it carelessness. It has been said by my students that it's easy to understand the concept, but because of carelessness, they get the wrong answer. So be very, very careful in solving. Well, you might be confident that you get the right concept, you get to remember how to solve something, but if you are careless, well, it's nothing. So it's best to always be careful with your solution. Okay? Oh, what is the value of x plus 5 squared a while ago? So I'm putting here a parenthesis. I'm not just directly input the value of this one here. If you are doing some expansion of the binomial here, you must always put the parenthesis. Always remember, whenever you make expansion and you have a negative sign there, so leave the negative sign outside, expand first before you distribute the negative sign. So again, what's the value of x plus 5? Now, a while ago, here is the value of x plus 5 squared. Where is it? Ayan. X squared plus 10x plus 25. Okay, so we have there x squared plus 10x plus 25. Oh, by the way, why did I look for that? It's easy. X plus 5 squared is actually, the middle is addition of 5, twice of 5, addition of twice of 5, and then this one is the multiplication, right? Twice of 5, addition of 5, twice of 5. A shortcut. Now, if you happen to get a hang of it, then you just comes out naturally. So 1 plus, again I will be putting parentheses to be very extra careful. So as I said a while ago, when you're doing expansion, always put the parentheses first. So put the expanded form inside the parentheses, so that whatever operation outside will be distributed correctly. Okay? So x plus 5 minus x squared, so we are distributing the negative sign, minus 10x minus 25. 1 plus, this is already x squared plus 10x plus 25 equals, combine like terms. So x here similar with negative 10x. The answer for this one is negative 9x. Then we have there 5, positive 5, then we have negative 5, 25. This becomes negative 20. So we are following the sign of the larger number, which is 25. Then, lastly, we have x squared over 1. So I used circle for the constant. So I'm using circle also for the constant in the denominator. So 1 plus 25 is 26 plus only 1 x squared, then only 1, then x. Then let's arrange it. Actually, you can have it already as an answer, but some professors or instructors would like a more organized or simplified one. So if ever that is the case, then we have here the numerator is negative x squared minus 9x minus 20, then denominator x squared plus 10x plus 26. Okay, so you can already have this one. Or you can have this form also, negative x squared. So we will be removing the negative sign for x squared, and the rest follows. Positive 9x, positive 20, divided by x squared, 10x plus 26. So that when you distribute this negative sign here, we will still be arriving at the equation in the numerator. Okay? So no problem. You can have two possible answers for this. Now that's for example number 3, letter B. Now let's go to the last one. So let's put another extra piece of paper. What is the last problem? Right? So you have there. What is the last problem? We have letter C. Example 3, letter C. So it says there, find f of 0, f of 2, and f of x plus 5 of letter C. So letter C is f of x, and another dreaded form in mathematics is the radical sign for minus x squared. Why? Students tend to be nervous whenever they see the radical sign. Okay? So let's do the operation. So always remember, this is the original equation. So we will be looking for the value of f of 0. So we will be substituting value of x with 0. Again, the parentheses. Never ever forget the use of parentheses. You got there square root of 4, because 4 minus 0 is 4. Square root of 4 is, yes, it is 2. Right? Next, we got the f of 2. Substitute the value of x with 2. So we have there 4 minus parenthesis 2 squared. Square root of 4 minus 4. Ooh, so what's this? Square root of 0. What's the square root of 0? Square root of nothing is nothing. So happy to see that nothing. So easy, right? Now the third one, the third and last example is f of x plus 5. Substitute the value of x with x plus 5. So that is 4 minus parenthesis x plus 5 squared. Now, what did we discuss a while ago? Expand first this one, but never remove the parenthesis. Expand it, but let the parenthesis remain. So 4 minus, expanded form of this is x squared plus 10x plus 25. Then, distribute the negative sign, x squared minus 10x minus 25. Oops. So, we have here a constant and constant. So, we have, what is 4 minus 25? That is negative 21. Minus x squared minus 10x. So that is, let's arrange this one. We have negative x squared minus 10x minus 21. Okay, I will be accepting this. Okay, so I will be accepting that. Another form is, if you don't like or you hate seeing radical sign, well, I will be accepting a exponential. We have there x squared minus 10x minus 21 raised to the power of 1/2. So these two is similar actually. The radical sign is converted into 1/2. This is actually the square root, right? So this is 1/2. Or another form of answer that I could accept with this kind of problem is when you remove the negative sign. You hate the negative sign. How? Well, it is square root of, so you remove the negative sign so that x squared becomes positive, 10x becomes positive, then 21. So that when you distribute this negative sign inside, you will still arrive with the similar answer. Okay, so we remove the negative sign. What happens? Well, you can have the answer of imaginary because you don't have any square root of negative number, right? It's imaginary. So, imaginary square root of x squared plus 10x plus 21. Okay, so that is the third possible answer. So that's how it is. That's the solution and the answer of the sample problems there in your lecture notes. You need to rewrite this in your notebook so as to embed in your mind, to remember the solution. You see, the more you use your hand, the more you solve problems using your hands, the more the idea is imprinted into your brain, the more you remember it. So I suggest you always practice solving these kinds of problem. I have given you already your resource, your PDF book, some sample problems to solve from the book, and whatever resources you find in your disposal, even though it's not included in our reference, you can use that. Search the internet and how to solve problems. You can do that. The purpose of having our classes is to introduce to you something which is, it might be new, to learn the basics, the fundamentals, and then later on, you apply that somewhere. You increase your skills, you increase your knowledge, because we cannot teach you everything in the classroom. Other ideas will be found somewhere. So, that's how it is. When you start to learn how to ride a bicycle, it's hard, but when you finish learning the basics of riding a bicycle, then you became passionate with riding bicycles. You start to learn tricks how to ride the bicycle. It's similar with mathematics. So you start with basics, you start with the beginning. There might be some difficulties, there might be some semplang moments, but the point there is you learn. So that's how it is. So this ends my lecture. The next topic will be limits. So stay tuned for updates regarding